Leiden geometry students. Today we're going to talk about angle pairs. That's two different angles together that do something special. And there's a couple different types that we'll be talking about. The first one is the 90-degree or right angle. 90-degree angles or right angles are used in things that we build all the time. These are angles that look like this. It's how the angle that your wall and floor are supposed to make together. That is a 90-degree angle. It's one of the most common ones that we run into. Other one that's very common that we run into is 180 degrees or a straight angle. It's just anything that's basically a straight line. We just call that 180 degrees. The third thing that we run into very commonly are intersecting lines. Here, we see an example where we have intersecting lines and they make four different angles. Most of the different angle things that we'll talk about the entire year boil down to one of these three. Either 90-degree angles or straight angles or two lines intersecting making four angles. The common problems we'll start with will look like these. Here we have examples of each kind. Down here on the bottom right, we have two angles that are making a straight line. They'll make 180 degrees. Here, these angles over here on the left bottom, they make a 90-degree angle. Up here on the top, these two angles are where two lines intersect in both cases. And then this middle is kind of a mix of all of them. We measure angles in degrees. And the smaller the angle, like here we have a little tiny angle, is just 3.4 degrees. As we make the angle bigger, the measure gets higher and higher until we reach a right angle, which is supposed to be 90 degrees. I don't think I can get it exactly there, but 90 degrees is a right angle. If we keep extending it to a straight line, we get to 180 degrees. Oh, couldn't make it. And you got to remember from previous assignments that any angle less than 90 we call acute, and any angle more than 90 but less than 180 we call obtuse. The problems we're going to look at will look something like this. Here I have a 90-degree angle. This one big angle is 90 degrees. If I break it up into two smaller angles, well, these two smaller angles that I've just created, the red one and the unmarked one, these two angles together make a 90-degree angle. So if this angle, the red one right here, is 40 degrees, we need to be able to find the other angle. Likewise with straight lines, here I have a straight line. If I know the measure of here, and I can break it up into two smaller angles, the red one over here and the blank one over here, but I know whatever their two measures are, they have to add to 180. So if this angle over here on the left happens to be 47 degrees, there we go, then I can find the measure of the other one next to it by making sure they add to 180. I'll just do 180 minus 47, which would give us 133 degrees for this angle. We do the same thing with the right angles. If I want to know the measure of this blank angle, we do 90 minus 40 to get the missing angle here, which is 50. As a vocabulary reminder, in those pictures I just showed you, we had two angles together making one bigger angle. When you have two angles together that share a vertex and a side, like these five you see on the screen here, they are called adjacent angles. Adjacent just means next to, but adjacent angles are angles that share the vertex and one side. So we'll start by talking about 90-degree angles. This is a 90-degree angle. This little box in the corner represents that. So if you see the box, you automatically know that it's supposed to be a 90-degree angle. And our most basic simple problems might look something like this, like what we just talked about. These two angles, the 60 and the x, together they're making a 90-degree angle because they're adjacent. So if I want to know what x is, I just have to figure out what do I add to 60 in order to get 90. So doing it the long way for this one, I might write something like 60 plus x is equal to 90 and solve that equation. We would just subtract 60 from both sides and get that x is 30. I know that seems like that's overdoing it for a problem like this. You think I could just do 90 minus 60 to get my answer without that setup. But as the problems get more complicated, you'll need the setup. But before we get to the complicated ones, we can also do these problems without even having a picture. From a previous assignment, we talked about what complementary means. Complementary means angles that add to 90. So here we have that same information, but no picture. We don't need the picture. What I'm going to ask you here is, what is the complement to 38 degrees? I'm asking you, what do you add to 38 to get 90? To find the answer, yes, you can do this a simple way, just 90 minus 38 and find the missing angle. In this case, you'd get 52 degrees. But the problems don't always stay this simple. We can take some of the problems and add some algebra to it. Here, like those easy ones, are two angles that add to 90. All right, setting up an equation turns out to be one of the things that people struggle the most with in first quarter geometry. But in this picture, you probably can look at this and say, I know those angles together are 90. Well, when we say that together they're 90, we're saying if we add them, we get 90 degrees. So if you add these, you get 90 degrees. We're going to actually add them, and then when we say you get 90 degrees, we're going to say that's equal to 90. So if we add the 3x, small angle, plus the 10x plus 12, the larger one, we should get 90 degrees. And we need to take that and write that as an equation. 3x plus 10x plus 12 is equal to 90. Then we have to solve this equation to figure out what x is, and then ultimately what the measures of both of those angles are. But solving it is stuff that we've now been doing for a little while. All we have to do to solve this equation, combine like terms. We get 13x plus 12 is 90. Subtract 12 and divide by 13, and we'll get 6. X is 6. Now I can ask another step here. 6 is the value of x. It's not the size of the angles. If I ask you to find what are the measures of those angles, you would take that 6 and plug it back in for x. 3x becomes 3 times 6, which is 18. 10x plus 12 becomes 10 times 6, 60, plus 12, 72. So we can actually find the actual measures of the angles from this information. This is an example of a hard problem having to do with 90-degree angles or complementary angles. Next, we're going to talk about angles that instead of adding to 90, they add to 180. To do that, I got to do a quick reminder of a vocabulary phrase from a previous lesson. A linear pair, these are adjacent angles that are making a straight line. So they're adjacent, they're next to each other, sharing a vertex and a side, but together, instead of adding up to 90, they're making a straight line, so they're going to add to 180. It's a long sentence to have to spit out, so we shorten that up to calling it a linear pair. Linear is line, pair is two, so two that make a line. But the problems that involve a linear pair, or that make a straight line, or of angles that add to 180, really aren't very different from the ones that added to 90. It's basically the same idea, except the pictures are different, so instead of adding to 90, they'll add to 180. An example of an easy problem, just like with the complementary angles, the 90-degree ones. Here, I know these two angles are making a straight line, so they have to add to 180. So 120 and x together have to be 180. So we get to write 120 plus x is equal to 180, and then simply solve that equation. We solve it by subtracting 120 from both sides and getting that x, the missing angle, is 60. Also, just like with 90-degree angles, we can do 180-degree angles without even having a picture. We use a word for this. It's supplementary. It's two angles that are adding to 180 degrees. So if I ask you, what is the supplement to 50 degrees? I'm asking you, what do we add to 50 degrees to get 180? So we just do 180 minus 50, and in that case, it turns out to be 130. Now, those are the easier problems. The harder problems might look something like this. Here again, we have two angles, the 4x plus 20 and the x minus 10, and those two angles add to 180. I know this because they're making a straight line. So I'm literally going to write this one and that one add to 180. One plus the other equals 180. And that's how we create the equation that we'll use to solve this problem. The first angle, 4x plus 20, plus the second angle, x minus 10, is equal to 180. Again, solving it is not that hard of a problem from Algebra 1. In this case, we just have to combine like terms and solve for x. If we do that properly, we're going to have 5x plus 10 is 180, and then simply subtract 10 from both sides and divide by 5, and we're going to get 34 for x. Like the other problems, if you were asked to find x, you're done. But if you're asked to find the angle measures, you have to take 34 and plug it in for x. 34 minus 10 would be 24 for this angle. And 4 times 34 plus 20, whoops, I clicked on the picture and it took me to a link. 4 times 34 plus 20 would be 156 degrees. So our two angles are 24 degrees and 156 degrees. The hard problems don't need pictures either. Here we have a problem where we're just going to use words. Angles A and B are supplements. That means they add to 180. Here's one measure, here's the other one. What's x going to be? Well, if we know they add to 180, we're just going to take one of them plus the other one equals 180. So 7x plus 4 plus 15x is equal to 180, and then simply solve that equation. Combine your like terms, you have 22x plus 4 is 180, subtract 4 and divide by 22, and we will get 8 for x. So as I said, there are three common types of angles we run into. The 90-degree ones, where the angles add to 90. The 180-degree angles, where we call supplements, the angles that add to 180. And the third type was where we have two lines intersect each other and create four angles. Before we talk about intersecting lines creating four angles, I want to talk briefly about measuring angles. To measure an angle, we need a tool called a protractor. That is this tool that you've probably had in a desk at some point in your life. Maybe you got one sitting around the house, but we use this to measure how big our angle is. First off, you see this angle on the screen, this black angle here. It's less than 90, so it's an acute measure. I know the answer is going to be less than 90, more than 0, and less than 90. But to be more specific, what I have to do is line the protractor up with it. For the protractor, I need to take this center of the protractor and put it on this vertex. So we drag it over so that the vertex of the angle lines up with this point here. Most protractors actually just have a hole there. And then we have to turn the protractor so one side of the angle passes through the 0 degrees here. So I'm just going to turn this thing until it reads right there. And then I read what number the other side of the angle is hitting on the protractor. In this case, it's 10 degrees, 20 degrees. It's not quite 30. It looks to be about 28 degrees. Now you might wonder, why did you use the small numbers instead of the big numbers? Well, it's because we already know this angle is acute. Its measure has to be less than 90, small numbers, so we use the small measurements. If it was an obtuse angle, we'd use the large measurements. So now we can talk about intersecting lines. To show intersecting lines, normally what we would do is have you draw this on a sheet of paper. Using a ruler, just draw a big X, two lines crossing each other. You take note that we create four angles when we do that. 1, 2, 3, 4 angles. And I'd ask you to measure these angles. And you'd take a protractor and you'd have to measure those angles. Now we're not doing that through the computer, so I'm just going to show you what the results would be when you do this. But I promise you, this always happens. You get some results like this. Now, you don't always get the same numbers. You may not get 75 and 105 for your measurements, but the same pattern always appears. Angles that are across from each other like this always turn out to be the same. So if you made your angles smaller and this one was 60, this one would be 60 as well. It's not just top and bottom, but the left and the right angles turn out to be the same thing as well. That always happens. Those angles that are across from each other and have the same measure, we call them vertical angles. There's a second pattern that always pops up that's a little less obvious, and it's that any two angles next to each other are making a straight line and therefore will end up adding to 180 degrees. So we have two rules that pop up whenever we see this picture. Two rules. The first rule is that angles across from each other always end up having the same measure. We call them vertical angles. And angles next to each other always end up adding to 180 degrees. And those would be called a linear pair in this case. So once again, here's the pattern. The angles across from each other end up having the same measure. Angles next to each other always add to 180. We have some special words to describe that, but our two rules. Angles across from each other are always equal. Angles next to each other in this picture always add to 180 degrees. So that first rule, the angles across from each other are always equal. The angles across from each other is kind of a long phrase. We're going to shorten that up and call them vertical angles. Vertical angles, which are the angles across from each other, are always equal. Now, we're not actually going to say equal anymore either. This is going to be another new geometry term, but this one will come up every day for the rest of the year. We don't call them equal. We call them congruent. Congruent is this symbol. You may have seen this before. It's an equal sign with a little squiggly line above it called a tilde. It's two things happening in math. You're used to just the equal sign. The equal sign means two things are the same size. You can have a circle and a square that have the same size or encompass the same area. But the little squiggly line, that's the new part, that little squiggly line means they're the same shape. Together, that's what congruent is. Congruent means the same size and the same shape. So the first thing you'll have to do in any problem that looks like this is identify whether the angles you're looking at are supposed to be equal or congruent. Their measures are equal, the angles are congruent. Whether that's the case, or you're looking at measures that add to 180. So if we look at these pictures, we're going to try to figure that out. Remember, if they're across from each other, they're going to be equal. If they're next to each other, they add to 180. Take a second and answer the questions on the side. At number 15, these two angles across from each other, they're vertical angles. Those two angles are equal or congruent to each other. In problem number 16, these two angles are next to each other, making a straight line. That means they're going to add to 180. And number 17, these are vertical angles again, across from each other. Their measures are going to be equal. Number 18, these are next to each other, making a straight line. They add to 180. Same with number 19. Next to each other, making a straight line. Their measures will be equal. But at number 20, they're across from each other again, so their measures, I said the wrong answer on 19. These are next to each other. They'll add to 180. But number 20, they're across from each other. Those two will be equal to each other. My apologies for that. So we're going to take a quick look at some easy, medium, and hard problems that involve two lines intersecting and creating four angles. Remember, angles across from each other are vertical angles. They have the same measures. They're congruent. Angles next to each other form a linear pair. They add to 180 or are supplementary. That's what it means adds to 180. So in all these problems, the first thing you have to do is look at the picture and decide which one you're looking at. In the first picture, we have these two angles. You have to decide right away, are they supposed to be equal or add to 180? In this case, they're across from each other, so the missing angle is going to be 100. These two are going to have the same measure. They're across from each other. In the second picture, these two angles are not across from each other. It's not top and bottom or left and right. You have two of them next to each other, so they're not the same. These two angles are going to add to 180. So to find the missing angle, we do 180 minus 110, and we get 70 degrees for that one. The last picture, we look at these two angles, try to decide if they are equal or if they add to 180. In this case, they're across from each other. They're vertical angles, even though they're going left and right. I know the name vertical can be misleading, but these two are supposed to be the same. They are congruent. They have equal measures, so our missing angle here is 120. A medium level problem might look like this, where we have some more x's floating around. But again, the first step is the same. You have to look at the picture and decide, are these two supposed to be equal to each other, or are they supposed to add to 180? In this case, these are angles across from each other. They're not next to each other. So these are vertical angles. They are supposed to be equal to one another. So in the problem like this one, we're going to say 48 is equal to 2x plus 6. And then we could solve for x. Subtract 6 and divide by 2. We're going to get x is equal to 21. If you plug 21 back in here, you don't really have to do it because we already know the answer is going to be 48, but you could check that if you like. Now this is when they're equal. We can almost do the exact same problem, but here I just moved one thing around, and these two angles with the same two measures as the last problem, they're not equal to each other. These are next to each other, making a straight line. These are supplements. In this case, these two angles are supposed to add to 180. So we'd have to say 48 plus 2x plus 6 is equal to 180, and then solve this equation. Combine your like terms. You have 2x plus 54 is 180, and then simply subtract 54 from both sides and divide by 2. We get 63. You get very different answers, even with the same numbers, depending on the problem, whether they were supposed to be equal to one another or they were supposed to add to 180. Finally, here's an example of a hard problem. We're going to have multiple x's in here, but it really isn't that much harder. The hardest part of the problem is still probably just setting up the equation. So you ask yourself, are these two supposed to be equal or add to 180? I know I keep repeating that sentence, but for most of the year, you're going to be asking yourself that question as a first step in lots of different problems. Are they equal or do they add to 180? In this case, these are vertical angles. The angle on the left and the right, they're going to have the same measure. These two angles are congruent. They're vertical angles. So if they have the same measure, we're just going to set them equal to each other. This one, 10x plus 22, is equal to this one, 12x plus 4. And then just simply go through the algebra and solve for x. We would subtract 10 from both sides, and have 22 is equal to 2x plus 4, then subtract 4 and divide by 2, we'll get x is equal to 9. If you were asked to find the angle measure, the actual measures of these angles, take the 9 and plug them in for x. 10 times 9 is 90, plus 22 is 112. If you plug in 90 for the other one, you should get the same answer.